Hello dear students, greetings for the day. In this video lecture, we are going to study the T0CON register. So before looking into the T0CON register, I will just introduce you to the concept of timers. There are 4 timers, namely timer 0, which may either be of 8-bit or 16-bit. Timer 1 is a 16-bit timer, timer 2 is a 8-bit timer, and timer 3 is a 16-bit timer. Okay, so in all there are 4 timers from timer 0 to timer 3. These timers can be used to generate the time delays using on-chip hardware. Okay, so see, as there are on-chip hardware devices, they can accurately keep the time in background while the PIC is performing some other functions. The basic hardware inside each of this timer is a register that can be incremented or decremented at the rising or the falling edge of a clock. So there are registers which can be loaded with a count for a specific time delay, and that's the purpose of using the registers. So time delay is computed by subtracting the initial starting count from the final count in a register, and then you have to multiply the subtracted result by the clock frequency. So timers can also be used as an event counter. Okay, so you have to note that an event counter is basically a register with the clock which is replaced by an event such as a switch. So the counter is incremented or decremented whenever the switch is activated only. Okay, this is very important thing to be noted. Thus, number of timers the switch is activated or occurrence of the event has arisen can be very easily determined. Okay, so basically you can just operate timer 0 as an 8-bit timer or a 16-bit timer, because I already told you that timer 0 is either a 8-bit or a 16-bit. Okay, so timer 0, it can utilize the internal clock when used as a timer, and it can utilize an external clock when used as a counter. So depending on the clock, you can just identify whether the timer 0 is operating as a counter or it is operating as a timer, because if the clock is internal, it means it is used as a timer, and if the clock is external, it means it is used as a counter. Okay, similarly timer 1 can also be used as a 16-bit timer or a 16-bit counter, and it cannot be used as a 8-bit. Why? Because timer 1 is designed only for 16-bit operations. Timer 2 can be used as a 8-bit timer using the internal clock. It cannot be used as a counter. Timer 2 is used only for the timing applications, and it cannot be used for the counter applications. And similarly timer 3, it operates as a 16-bit timer or counter and not as a 8-bit, because timer 3 is only a 16-bit timer. So timer 1, 2 and 3 are basically used by CCP module for compare, capture and PWM operation. Okay, whereas timer 0 is not used by the CCP module. So timer is basically a binary counter which can be programmed to count the clock pulses. So when the timer reaches the maximum value, suppose if it is a 8-bit timer and it is reaching its maximum value as 0xFF, okay, and if it is a 16-bit timer, it has to reach its maximum value FFFF. So it will roll back to 0. Okay, rolling back is nothing but the process of overflow. Okay, so this thing is very important. So this is just the prior concept. Okay, so as I told you that timer 0 can also operate as a counter. So you can see this timer 0 operating as a counter. So this is very important question, that you have to draw the T0CON register and explain the function of individual bits of T0CON. Or you may have a question like, try and explain the T0CON register and explain the use of prescaler. There are two important parameters which are related to the T0CON. Those are prescalers and postscaler. I'll just define those terms after explaining the T0CON register. So on the screen you can just see a T0CON register. Okay, it is a 8-bit register. It's a 8-bit register starting with bit 0 over here and bit number 7 over here. So 0 to 7 is 8 bits. Okay, so timer 0 can be used as a counter. So the timer 0 can be configured as a counter by setting the TOCS bit. TOCS bit is bit number 5. You can see it over here. Okay, bit number 5 is TOCS. Okay, you have to set this bit and then it can be configured as a counter. It is a counter. Okay, so we know that T0 timer can either be used as a counter or a timer. So if you want to configure it as a counter, you have to set this bit. Setting this bit means we have to make it 1. So this will enable the PIC 18F458 to be used as an external clock. And also we know that whenever there is an external clock, it means the device will be used as a counter. And if it is an internal clock, obviously it will be used as a timer. Okay, so you should know the individual pins function. So here bit number 7, this is bit number 7, timer 0 on. So you have to on or off the timer. Okay, so for that purpose bit number 7 is used, that is timer on. Okay, so if this bit is 1, it means your timer is on, and if this bit is 0, it means the timer is off. There is a second bit, T08 bit. Okay, T08 bit. It is at bit number 6 position. So basically if this bit is 1, timer 0 is configured as 8-bit timer or a counter, and if this bit is 0, it will be configured as a 16-bit. So as we know that a timer 0 can be used as a 8-bit or 16-bit. In the introduction itself I told you that. So this will be decided by this bit number 6, that is it can either be used as a 8-bit or 16-bit, whether it may be a timer or counter, because there is a specific bit TOCS, okay, which will tell that we are going to set this bit for what purpose. Okay, so this 6th bit, it only tells us about whether your device is a 8-bit or a 16-bit. Okay, and this 5th bit, what it is telling us about, it is a bit number 5. It is telling us that we have set the device as a counter. Okay, so when this TOCS bit is 1, it means external clock is connected. Okay, and if this bit is 0, it means it is a timer, and if it is a timer, you should have a internal clock. See, you can see it here. If it is 1, you can see a external clock, and if it is bit number if this bit is 0, it is a internal clock. Okay, next bit is bit number 4. This one, it is TOSE, timer 0 source age select bit. Okay, so if this bit is 1, increment on high to low transaction of a T0 clock 1 pin. Okay, so how the depending on the ages of the pulses, whether on which transaction it is going to change from high to low or low to high. So if it is 1, it means it is changing from high to low. If this bit is 0, it means it is changing for the transactions from low to high. Then you have the bit number 3, that is PSA, timer 0 prescaler assignment bit. Okay, timer 0 prescaler assignment bit. So what is prescaler? Prescaler means the timer clock frequency is divided before the frequency is used by the timer. Okay, keep in mind, whenever you divide or whenever the timer clock frequency is divided before the frequency is utilized by the timer, then it is called as prescaler. What is postscaler? It divides the clock by an integer after the timer is used. Means you have to utilize the timer first and after that you have to divide the frequency. Okay, this is called as postscaler. Pre means before, post means after utilization of timer. You have to divide the timer clock frequency. It's a very important point as far as this T0CON register is concerned. So this bit number 3 is PSA, timer 0 prescaler assignment bit. So if this bit is 1, okay, timer 0 prescaler is not assigned, and if this bit is 0, timer 0 prescaler is assigned. Okay, you have to assign that bit for identifying the prescaler. Then you have bit number 2 to bit number 0. It's a range. You can see it here from bit number 2 to bit number 0. It is T0PS2 up to T0PS0. This is timer 0 prescaler select bit. Timer 0 prescaler select bit. So as it is a 3-bit, see these are 3 bits. Okay, so it is a 3-bit. So timer 0 prescaler select bit, if it is 111, it means its prescaler value is 1:256. If it is 110, its prescaler value is 128. Depending on assigning this binary value to these 3 bits, we have this prescaler values. Okay, so these are all different variations which are there for these 3 bits, and depending on that there is a prescaler value. Okay, so this was about a T0CON register. So it is a 8-bit register. It can also be a 16-bit, but explanation which I have given is for 8-bit. Okay, so function of each pin is also seen over here, along with the terms of prescaler and the postscaler. Coming to the simple numerical over here, find the timer's clock frequency and its period for various PIC 18 based systems with the following crystal frequencies, and assume no prescaler is used. You have been given different frequencies of say 10 megahertz, 16 megahertz and 4 megahertz, and you have a simple diagram. You have a crystal oscillator and it is divided by 4. Okay, this diagram is given. So I'll just show one sample. We will take the first one. Frequency is how much? It is 10 megahertz. Your frequency is 10 megahertz. So for this frequency we have to find the timer's clock frequency and its period. Okay, so this is a crystal oscillator frequency. You have to replace this value over here. So 10 megahertz frequency divided by 4. So we will just divide it by 4. What we will get is something around, it is 2.5 megahertz. It is 2.5 megahertz. Okay, what is this? This is clock frequency. This is clock frequency. Then we have to find out the period. Okay, you can see here we have to find the 2 parameters, that is clock frequency and period. We found out the clock frequency. How? By just dividing the crystal oscillator frequency by 4. Then we have to find out the period. T is equal to 1 upon f. We know that formula. So you have the frequency, just take its inverse, you will get the time, and your time is nothing but it is 0.4 microseconds. Okay, this calculation is done for the crystal oscillator frequency of 10 megahertz. On similar lines, we can do the calculations for crystal oscillator of 16 megahertz frequency and 4 megahertz frequency also, so that you will get the clock frequency and the period. Coming to the next point, you have to find the timer's clock frequency and its period for various PIC 18F based systems with the following crystal frequency of 16 megahertz. Assume the prescaler value of 1:64. Okay, so crystal oscillator frequency, you have to divide it by 4 divided by 64 because prescaler is given as 64. Okay, so we have to divide it by 64 and then you have to give it to the timer. Okay, as it is a prescaler, we have to first divide the frequency and then give it to the timer. Okay, if it would be a post scaler, then this division would be done after the timer has utilized the frequency. Okay, so what is the crystal oscillator frequency? It is 16 megahertz. So 16 megahertz divided by 4 is equal to 4 megahertz. It is equal to 4 megahertz, right? Yeah. So after you get this division as 4 megahertz, again you have to divide it by 64. So dividing this 4 megahertz by 64, we will get it as 62,500 hertz, which is almost equal to 62.5 kilohertz. Why we are getting this value? This is just because of prescaler. This is just because of the prescaler. Okay, and to find out the time, what to do? See, you got the frequency now, it is 62.5 kilohertz. Take its inverse, you will get the time as 16 microseconds. You will get it as 16 microseconds. Coming to the next one, assuming 4 megahertz crystal oscillator, calculate the time delay for the following PIC 18F instruction sequence. You have this set of instruction: move LW0xD4, move WF-T0CON, move LW0x80, move WF-TMR0L, and this is the timer register, 8-bit timer register, and these are the values which are given, setting and disabling of the bits. Okay, so for this we have to find out the delay. So from above program, we know what these instructions are going to do. Move LW, it will move the literal value into a working register. So here W will be equal to 0xD4. Move WF T0CON, working register contents are moved to the file register. You can see here, this is a source and moved to the destination, that is file register. Okay, literal then in move LW, literal value is moved to W. Okay, what is literal value now? It is 80. It is moved to W. Move WF, that is timer 0L, that is contents of WREG are moved to the file register location, that is TMRL0. Okay, so we have to do the calculations. So from this you just see the bits. Timer 0 is on. Okay, T0 8 bit is equal to 1. It means it is configured as a 8-bit timer. T0CS bit is equal to 0. It means it is internal clock. Okay, so TOSE is equal to 1. It means it is going to increment from high to low. PSA is 0. It means prescaler is enabled. TOPS2 to TOPS0. It means these 3 bits are 100. it means you have to check the table and the prescaler value found is 1:32. So for time delay calculations, you have the crystal oscillator frequency as 4 megahertz. Okay, it's a clock period. So 1 divided by 4 megahertz is equal to 0.25 microseconds. So instruction clock period we have to find out. Instruction clock period is nothing but 0.25 into 4. Okay, it is equal to 1 microseconds. But we have to find out the time delay. Time delay is found out by using this formula. Time delay is equal to instruction clock cycle multiplied by prescaler multiplied by counter. So it is 1 microseconds multiplied by 32 multiplied by 128 is equal to 4096 microseconds. Okay. So how did we get this 128 and 32? 32 is nothing but the value of a prescaler. What is 128? 128 is the decimal value of this count. You can see this is a count. 0x80 is a count which is given. So if you just write this 80, how do we write 80 in binary? It is something like this, right? 8 and these are zeros. Okay. So if you just take its equivalent, it is 128. Okay. So in this way we got this 128 and it is equal to 4096 microseconds, which is equal to 4.09 milliseconds. Okay. So in this way we just saw the insights of T0CON registers and some of the numericals based on this. Thank you.